So your payment module for your charge controller can be your Bitcoin full node with your Lightning Network node running on it. And so basically with the distributed charge project, you kind of get a full node, it's kind of part of the package, which is kind of cool. But then as like a car owner, you probably don't want your full node running around in your trunk of your car. So in that case, you'd use the Board A0 with the Tofu with a cellular radio, and then you connect back to your full node back at your house or something. It's running your Lightning node.
Hey, what's up, everyone? Welcome to another episode of Changing the Tide. I'm John Crabtree, your host. Today, I am stoked. I have Andy Schroder joining me. He's an engineer, mechanical and aerospace. Back in 2013, he created a project called the Bitcoin Fluid Dispenser. And essentially, it was almost like a Bitcoin gas station, but it's not just fuel fluids that could be used. It was almost anything. However, he thinks use case-wise, fuel fluids followed by water would probably be the two biggest use cases. But it's an automated dispenser of fluid that he rigged up using pretty much open source software, from the tablet that he used to Android phone OS, an interface, web interface there, and then a bunch of old, an awesome looking truck. So you should check that out. That is on his website, which will be posted here in the notes. And then a couple years ago, when electric cars started gaining steam, so to speak, then he found a way to connect to the native Tesla charging port and actually created a system along with what's called the A0 board, which is, he calls, what will be the backbone to a Bitcoin and Lightning native energy grid. If that sounds awesome to you, just wait till you hear him. But then it's a way to exchange using small micropayments per time period. I think it's per second. You get a certain amount of watt hours per second, and I think it's something like you pay for chunks of 15 to 25 seconds. But it's a way to stream sats to someone who has a charging port. And so he's really looking to distribute, charge, and create private peer-to-peer electric car charging ports. So I'm excited. Let's dive in. He is an incredible mind, and you'll see that both in our conversation, but also on his website. Andy, welcome to the show.
Thanks for having me.
Yeah, I'm excited. As we dive in here, let's go to the Clark Moody dashboard. We are currently at block height 723,603. There are 90.29% of Bitcoin that will ever be issued have already been issued by miners, and there are 15,231 reachable Bitcoin nodes, and there are it looks like 20,062 Lightning Network nodes. And if Andy has anything to say about it, there will probably be a whole lot more than that in the future. So Andy, I'm excited to have you on about two projects you've been working on, and but essentially from your website you say that you're working on integrating Bitcoin into the energy industry and any machine that sells a product or service. That sounds exciting.
Yeah, so I guess the most recent thing I've been working on is the distributed charge project, and that kind of focuses on automated payments for electric vehicles for a charge. It's mainly focused on public charging stations. In the past, I worked on the Bitcoin Fluid Dispenser. That was kind of my first endeavor into Bitcoin and automated systems, and there were quite a few prototypes there that I did. We can maybe dive into that project a little bit if you're interested. But
yes, please.
In general, with distributed charge, I've had a lot of insight from that earlier project, and I have this new hardware product called Board A0 that it's really specific to enabling the distributed charge project, but a lot of thought was given when that board was designed to kind of help enable things like the Bitcoin fluid dispenser to be a lot easier to set up in the future at a lot of kind of less desirable setup steps, and I want a product that kind of enables all of these applications. I think the electricity metering is kind of the most exciting, but there's so much to do, and I want other people to kind of be able to use this product Board A0 to do things that I haven't really thought of yet, and that's kind of the cool thing and the flexibility that was considered when it was put together. So would you like me to dive into more detail on what the Bitcoin fluid dispenser was, or how I got to that point, or?
Yes, it seems like that's the kind of first building block, and I think it'll illuminate for listeners, into the problems you're trying to solve.
Yeah, so I guess kind of the highest level problem here is, I want to do what I can to increase both the utility and the adoption of Bitcoin, and like I said, the Bitcoin fluid dispenser was kind of the first thing. Back in the day, when I was working on that, electric cars kind of weren't really a thing. So that was kind of the natural first step for me as a mechanical engineer. Trying to make some sort of device that helped increase the utility of Bitcoin. And I guess where I was really trying to focus was like targeting how do we onboard markets for commodities that are regularly consumed by society, to help kind of increase Bitcoin adoption, because we really need like the value of Bitcoin to be anchored to what you can purchase as far as something that you consume for your kind of daily subsistence, as well as a modern lifestyle that you may be interested in living. And the energy commodity is very critical in that, and I'm pretty focused on energy and all forms as a mechanical engineer, and so that's kind of really where the Bitcoin fluid dispenser kind of came from, and basically what it was kind of a series of sort of two and then kind of like a third variant of kind of the second prototype. But basically I focused on metering diesel fuel with a Bitcoin sale process, and basically it was using on-chain transactions, so kind of before the Lightning Network came around, and I was doing diesel fuel just because it's a lot safer to prototype with than gasoline when you're dealing with electrical circuits and whatnot. But basically what the machine did was the first version was kind of like a maker mashup of a lot of different stuff built into a truck. So I kind of had like a mobile fuel dispensing system that I developed that accepted a Bitcoin payment using a mobile phone, and it was portable on the truck, which was kind of cool, and just kind of presented a new way that Bitcoin could kind of enable something different. I mean, there are fuel trucks like airports and stuff, but back at that time I don't think they had on board payment systems, so that was kind of something new there. But anyway, the process for payment involved like a prepayment for fuel, kind of like if you were to go into a fuel station, make a cash payment to the teller, and then the device metered fuel and measured the fuel, and then if you got to your prepayment limit, it would shut off, or if you stopped and requested a refund, then it would send a payment back to you. And basically there's the mobile version, and then the second version I integrated into kind of a more traditional fuel dispenser cabinetry. And then kind of the variant of the second version included some cool features like Bluetooth communication and offline payments, and NFC was incorporated to kind of do away with QR codes with the phone that you might be making payment from, because a lot of people aren't really thinking about this, but QR codes don't really work very well in direct sunlight. And Bitcoin's gonna move to all types of vending machines that are outdoors. The QR codes really need to go away. We need to switch to NFC because it's just a tap-based system. Are you familiar with NFC?
Yes, near field communication. Yeah, absolutely. One of my guests on episode 7, NVK, he and his company CoinKite are creating or adding that to their popular hardware wallet, the Cold Card wallet.
Okay. So what are they doing with that?
I think what it enables is, for instance, there are several of the mobile wallets now that could pass a Bitcoin transaction, I believe, using NFC, or sign it, I should say, not pass it.
Okay.
So they're enabling that.
Gotcha. So basically, it's a way to have like a second factor of authentication on your phone for Bitcoin, or maybe the primary authentication. I guess depending on however you have it set up. Okay.
Right. Which you included on that was the third iteration. Is that correct, or was that the second iteration of your project?
So the first iteration was I called it the original Bitcoin Fluid Dispenser, and then the Bitcoin Fluid Dispenser 2, and then I called it the Bitcoin Fluid Dispenser 2.3. So the original Bitcoin Fluid Dispenser was the kind of mobile mashup, I'll say, built into a truck. And then the Bitcoin Fluid Dispenser 2 basically reworked the controls into a more traditional fuel dispenser housing, and it had a lot higher precision because I used a different flow meter type, which is the type that's used in fuel stations. And then the 2.3, the features that included were Bluetooth, near field communication, offline payments. So the actual payment, the signed Bitcoin transaction from the user's wallet could be transmitted over Bluetooth from the phone to the dispenser, and then the dispenser could then relay that signed transaction through the Bitcoin network. So point of that was the user didn't need to necessarily have an internet connection in order to purchase some fuel, because opening up like a free Wi-Fi hotspot at any gas station starts to become a little problematic from like a abuse perspective. So we got the Lightning Network now, so Wi-Fi could be sort of a instant pay per use thing, but at that time it wasn't really practical. And and so that was kind of what the offline payment through Bluetooth was. And the way it worked is you had to have like a certain number of known UTXOs on your mobile wallet, and then you could, if you had all those stored, then your wallet could assemble a transaction, assuming there wasn't like another copy of your wallet running on another phone or something that you had that was online within the time frame that your phone that you're currently using went offline. Does that make sense?
Yeah.
So pretend you and your wife both had the same wallet on two phones. She couldn't be online using up the UTXOs while you're offline. That wouldn't work. But if you had a bunch of UTXOs, in the wallet, then the probability was a lot lower. Even if you did have two people using it, that you'd have a problem. But
because essentially that's preventing a double spend issue.
What, preventing a double spend?
Andy? That particular problem solution?
Well, the offline Bluetooth communication, all that really did was it basically enabled people to make payments if they didn't have internet where they're trying to buy fuel.
Okay.
So
got it.
Say you're in the mountains at some fuel station, you need to fill up your truck, and there's no cellular. You can get some fuel and get on, basically. So that particular problem, I actually don't have solved in the distributed charge project yet. There's some ideas I have that are totally different than this one, but with each iteration here, I've kind of added some features and taken some away. The portable version in the truck had some cool things where you could monitor the metering process over the web of the dispenser, and I kind of took that away in version 2. That's kind of, some things I think are more critical than others, for this first step. And distributed charge, as we'll talk about, that was kind of a big architecture shift from liquid fuel dispensing. I guess just one final point of clarity between the different versions. I had version 2 and version 2.3 because version 2.3 was, I think, pretty much all software changes. There are no hardware changes. So they're really like 2 hardware platforms and then 3 different kind of software implementations of the Bitcoin fluid dispenser, if that makes any sense.
Yeah. And I want to go back to what you talked about, increasing the utility of Bitcoin, increasing it as a medium of exchange in this project. It was very interesting because a lot of the problems you're solving with this type of project solve other problems that I've seen other Bitcoiners be interested in. So, for instance, one of the possible applications you list is the bulk dispensing of milk and honey by producers directly to consumers. Now, the reason that's important is think of the milk containers you waste every week. And also, wouldn't it be great to reuse containers and buy fresh milk locally rather than from who knows where? And so that was an interesting point of you're thinking of multiple use cases, some of which go down to, like you mentioned, commodities that you use every day to live on, for instance.
Yeah, I think the milk and honey statement, that was kind of more to keep the point a little poetic. I don't know that that's the first. It's probably one of the last applications with the way modern behavior patterns are for consumers here. But I was really just trying to expand people's ideas on what this might do. But I think the liquid fuel is the biggest one because it's a really high value product that people consume. It's a high energy density material. But yeah, I mean, maybe there'll be the milk dispenser someday. I'm not sure, but I just want to keep people open minded, I guess. So
Yeah, it's the agricultural problems. Modern agricultural methods, though, in a lot of ways have disrupted the food
yeah.
supply. And so that was just an interesting side note you made. As well as the water delivery trucks for areas where city water is not available and a family may consume more water than their cistern or well
Yeah, I
collects.
think that one's a
Which
lot
is-
more realistic for people than the milk one, because you could be getting 1,000 or 5,000 liters or gallons or whatever your cistern size is of water, and that's going to be a lot more value than just a couple jugs of milk at a time. So yeah.
Sure. Sure. Also, you mentioned about the advantages of this type of uh, dispenser. And just to kind of hammer home your point, the purchasing power of Bitcoin can be anchored to a diverse set of physical commodities that are regularly consumed by society, and not just a handful of unstable centralized currency exchanges or collectible commodities such as gold and silver.
Yeah, so back in 2013 when I started the Bitcoin Fluid Dispenser project, there were very small number of currency exchanges, so that statement was a lot more critical at that time than it is now. I mean, now I don't know if there's 50 or 100 exchanges easily out there, and at the time there was like 2 or 3 maybe. That was a pretty rocky situation as far as that goes. Gold and silver are pretty strong value anchors for society, but I made that statement consumed, and you're kind of reading off statements from my video there, but I also kind of said it at the beginning of our chat here. The commodities really need to be consumed for them to be something that's really ingraining the purchasing power of Bitcoin directly into the economy. And I really think it needs to be like a lot of different consumables, not just a single one, so that we kind of have like an average type of demand of purchasing power for Bitcoin. People need to physically see what their Bitcoin can provide for them, in order for this thing to be really baked into the economy. That's kind of the point there, I guess.
Yeah, it's a common, let's say from outside, people who do not know Bitcoin yet and are just learning about it. It seems to be a common pushback. What can I get for Bitcoin?
Yeah,
So-
I mean, these kind of machines that I'm working on they're interactive, so people can kind of see and feel what Bitcoin is doing, and I kind of want people to use that as kind of like a bridge for them to what Bitcoin can be. And the big thing here is like, I'm just sitting around at my property working on this stuff, and I don't really need anyone's permission to do any of it. And that's really kind of an enabling thing of Bitcoin is there's nobody else that I need to involve. I just need to run software. I've had to kind of cobble sort of these hardware devices together, which was a little bit of a nuisance, but this board A0 that I mentioned is kind of my new product here. That's kind of aiming to try to make things easier for people, but it's not a requirement. I mean, they can use other things if they want to make it work. It's just how streamlined do you want it to be. Whereas some other systems out there in the world, it's like it's impossible to get something going as a little guy. And then now there's maybe intermediate companies that provide sort of more facilitating services, but then you've got yet another like intermediary there, and it's just like we need to get things a lot more direct and simplified is kind of the goal.
Speaking of intermediaries, what you list as a big advantage of the Bitcoin fluid dispenser is the fact that there are no credit or debit card intermediaries or banks in between taking a cut of the actual payment itself, which leaves more to the actual person who owns the dispenser and is running it. Same with the distributed charge project, I imagine as well.
I think the distributed charge project actually, electric charging kind of has it a little bit worse because a lot of these charging station operators, they're trying to create their own little network, and then they want you to install like an app dedicated to their chargers, and then that's really annoying because you have to have an app for every charging network, and then you have no idea like what they're gonna want to do as far as permissions on your phone with their charging app, and then other ones want you to use credit cards, which is not a lot different than like a fuel station these days, but it's still annoying, and because it's just not as automated of a user experience. But then like other charge station operators want you to have like sort of like a little card that you swipe, so there can be a lot of like accounts set up with these different operators, and it's just like that's a problem for the consumer. But then if these networks get big enough, then it's like an individual or a small business can't easily set up a charger on their property without partnering with one of these groups, and then how do they decide which one to partner with? And then it's just really not making for a good user experience for the car owner. And then there's not a lot of incentive for property owners to even put these things up, and we really need chargers everywhere if electric cars are going to grow. So, I am kind of creating yet another network, but I'm hoping it's a more open one, with the distributed charge and electric cars. So, I guess everything's got to start somewhere, but right now it may feel like the same barrier that the other people have created, but I'm hoping that barrier falls down over time as kind of the technology evolves on my end. So
yeah, well, let's talk about that project, distributed charge and Board A0.
So the Bitcoin fluid dispenser was going on, and now we know that on-chain payments aren't scalable, but at the time that wasn't really a known thing. So I had to work with what I could there and build that technology at the time. But once the Lightning Network started to become kind of more clear, and it became kind of obvious that it was going to work, I began working to retrofit the Bitcoin fluid dispenser to use Lightning, but the whole prepay and refund process in it started to look a little bit more difficult. You could provide a change address to the dispenser in order to kind of have sort of help keep things at least better privacy with that refund process by having a unique change address come back from the dispenser when it gave you your credit back. But with Lightning, payments are onion routed, and that's kind of like great because you have all this privacy, but then how do you get a refund back if you're onion routing things without divulging your Lightning Network node? So I started kind of thinking about that issue, and then I started thinking about the self-paying car. Could I have a fuel tank that I measured the level, and then the car automatically paid for fuel? And I started working on that, but then it's like, well, these level gauges in cars aren't very accurate, and you got fuel sloshing and then foaming, and it just didn't really seem, I guess, like it was the best path. So then that was kind of the time frame that electric cars were starting to come more into the forefront, and I started thinking about that, and it's like, well, it's really easy to measure electricity. Battery charge state is also pretty easy to determine. Maybe this self-paying car should be an electric car, and then it's like, well, electric cars also have a communication link between the car and the charger, so that's even better. And so that's kind of how I shifted to distributed charge project. And what distributed charge is it's a way for an electric car to have an onboard payment module that communicates with a charge controller that also has a payment module, and the car makes very small payments to the charge controller over the entire charging cycle for the electrical energy that's delivered to it. And so what's cool about this is both the car and the charge controller are metering the energy transfer, and so they can both minimize their risk. So the car makes a small prepayment, and then the charger delivers energy, and the car doesn't make an additional payment until it sees some energy is coming. And so then the charger, it won't send more energy unless it sees the next payment come. So there has to be a little bit of overlap in payment from the car to the charger, but it's like extremely small. So it's not a trustless system, but trust is minimized, and it's really able to be minimized by both parties in how that works. So does that make sense?
Yeah, it does. Yeah, it very much does. So it sounds like you have micropayments happening on a pretty regular schedule, so that the energy dispenser realizes, okay, I have this payment, so I can distribute this charge.
Yeah. So the when you pull up to this charge controller, there's like a little screen, and before you start charging, it kind of presents to you the terms of the sale. And initially here, I've got the rate is 1 sat per watt hour, or 1 watt hour per sat. It's the same thing because it's unity, but and then the payment size is 25 sats. So you have to pay 25 sats per payment. And right now I'm running it like close to 6 kilowatts for the charge rate for my demonstration. And so that comes out to about a payment every 16 seconds, just to kind of give you a handle on the frequency there of the payments. 25 watt hours, it's a very small amount of energy that you might be making a payment for. So if you're the car and this charger becomes faulty and stops delivering you the energy, you're not going to lose a whole lot, basically. And it's so small, in fact, that if you choose to unplug your charge cable and stop charging, you're kind of forfeiting that remaining prepayment that you might have made between that moment and then the previous micropayment. So it's almost like the payment size is so small that I just chose not to even worry about a refund between that short interval. And the car does have to pay ahead, so that the charger doesn't really have any risk actually at all. Well, actually, let me take that back. When you first plug the cable in, the charging starts up immediately. So that there's a moment when you first plug in where the charger's taking a little bit of risk, but then the charger makes the car make prepayments ahead then. So as soon as the first a few seconds of charging occurs, then the risk is totally off of the charge controller, and it's all on the car's end. And if that makes sense. There's a few situations. One, the energy measurement, there's always going to be kind of some error between the car's metering and the charge controller's metering. So there is some tolerance to those constraints in kind of percentage terms that kind of relax the rules a little bit. But that the design, assuming no error, is that the car always prepays in advance after the charge process kind of reached a steady state. There's a little bit of a transient there when you first plug in, because the car has to receive the kind of the offer from the charge controller as far as how much it wants you to pay for the energy that's delivered, and then the car can kind of accept or reject that. And if the car rejects the rate, then the charger just kind of turns off the charging to the car, and then everything pretty much stops. And the charger lost a little bit, but it's just a risk of doing business. Maybe it lost a few watt hours basically. But does that clarify things at all for you?
Yeah, I'd say so. That makes it a lot easier to understand how that payment flow is happening in the energy dispensing going back the other way.
Yeah, in one of my videos, I demonstrate what happens once you're mid charge cycle and the car might stop paying. And I kind of demonstrate live there where the charger cuts off power. It opens the contactors, and it's just kind of demonstrating this don't trust, verify approach in action basically. It's cool because that's going from Bitcoin, then it's able to have the don't trust, verify thing happen kind of in connection with the physical world. So I think it's pretty cool that Lightning Network micropayments can enable this kind of workflow basically.
And again, you didn't ask for permission. You just started building.
Yeah.
And I think what's interesting is you use this open network to tap in, because the first network that you've tapped into is Tesla's, but that's a closed network. So that's interesting.
Well, I mean, I was a little frustrated with their closedness of their charging network, and that's kind of why I wanted to create this. I guess one thing, Tesla being kind of a closed thing, all of the hardware that I have is part of this payment module and the car, and then the charge controller. It's wired directly to the components in the car and the charge controller, respectively. And there's a lot of people out there making services or whatnot for Teslas that use a web-based API that Tesla provides to connect to the car. And I see that as a really weak, kind of risky link to rely on. So I went through a lot of effort to connect directly to the components in the car so that if there's ever any kind of issue with that API, either intentional or unintentional on Tesla's side, I'm trying to minimize the impact on the distributed charge project, still working, because it's really dangerous to me to have somebody else in the middle of this whole process. And, I only want to provide solutions that avoid that.
Yeah, so you're doing whatever you can on your end to eliminate as many intermediaries as possible.
Yeah, I mean, you have the need for an internet connection, and then you need a Lightning Network, connection. But, I guess the internet connection is really where you need to ask the most permission for, because you have to have some service provider in order to get that. But the good thing is there's a decent amount of competition for internet providers that, right now at least.
One of which is Starlink, which is I guess that's a SpaceX project, but the sister companies, I guess.
Yeah, I mean, the cool thing is, you can run Lightning over cellular, you can run it over Ethernet, fiber. There's a lot of different ways you can connect to, cable modem. You can connect the Lightning Network, through different means, and that really kind of gives some, I guess, redundancy and choice there to make it a little bit more resilient.
And maybe dive into how board A0 then is kind of the the crux of this.
Yeah, so back in 2020, I kind of released the proof of concept for the distributed charge and kind of presented the details I just described to you there as far as how these payment flows work, from the car to the charger, and how the negotiation of price occurs. And if you take a look at that video and some of the photos that I published, it's kind of a little bit overwhelming for the average person to really want to tackle. There's just a lot of wires and special components, and there's a lot of components, and it just wasn't really very friendly. So since then, I've been working on more of an integrated product, and there's a special component that I'm calling board 0 that really came out of that effort. And board A0 is it's a circuit board that has some special functions on it to connect to the Tesla Model 3. It also connects to the Tesla Gen 2 wall connector, which it's basically like a charge controller, pretty much, for AC level 2 charging. And basically, board A0 has all the inputs and outputs required to connect to those two things. And there's some special stuff that didn't really exist in a single product that was required to communicate between those two devices over the charge cable. So the charge cable has power. It also has communication, and making the communication something that was tightly packaged together was a little bit cumbersome, and that's really a very unique part of board A0 is the ability to do that communication over the charge cable in a compact product. Some other things that board A0 does is it has some relay outputs as well as digital inputs, analog inputs. Those things aren't needed for the most part on the distributed charge, like electric vehicle application, but they're there because they can be used for other types of electrical energy metering applications with Bitcoin. And they can also be used to kind of upgrade the Bitcoin fluid dispenser to some more modern hardware. You could make a vending machine that uses Lightning Network with board A0s, relays, and digital inputs. So once I started working on board A0, it kind of turned into something for me that was more than just electric vehicle and Lightning Network. It was, what can I do to make a really general purpose product that can enable a lot of Lightning Network, interfaces as far as vending machines goes. And another key thing about board A0 I want to point out, it's designed to fit and kind of integrate with another product called the tofu that a company called Ortec sells. And the tofu is, you can kind of think of it as a motherboard sort of for a Raspberry Pi 4 compute module. Have you heard of the Raspberry Pi 4 compute module?
I have, yeah.
Yeah, so if anybody doesn't know what that is, it's like a kind of a, it's basically the CPU and graphics and Wi-Fi, etc. of a Raspberry Pi 4, but it's on kind of a smaller chip with some headers that you can then build a more custom board around it for a lot of specialized applications. And the tofu just happens to be one of those boards that's built around the Raspberry Pi 4 compute module. What's cool about the tofu is it has a wide voltage range for power input, which is great for doing things like plugging this thing directly into the Tesla's 12 volt power bus. And it's also good for installing in industrial control systems, out in the field. So that's pretty cool. But, even more critical is it features an M.2 socket, which allows you to put a SSD on, which you can then run a Bitcoin full node straight on this thing without, a lot of clutter. A lot of the other Raspberry Pi 4 Bitcoin full nodes out there have like a loose USB disk that's required for the Bitcoin blockchain, but with the tofu and an M.2 SSD, it's super slim and compact. It's there's nothing loose about it. So I really built this board A0 around the tofu because I think the tofu is really the ideal Bitcoin full node that people need to start really becoming aware of, basically. And then the last thing about the tofu that you can do with that M.2 socket is install a cellular radio instead of an SSD. So probably going to publish a schematic in the next few days that might explain this a little bit better. But right now, kind of the workflow, or maybe not workflow, but architecture is you've got your charge controller, it's got board A0 on it, it's got the tofu, and then it's got that solid state disk. So your payment module for your charge controller can be your Bitcoin full node with your Lightning Network node running on it. And so basically with the distributed charge project, you kind of get a full node, is kind of part of the package, which is kind of cool. But then as like a car owner, you probably don't want your full node running around in your trunk of your car. So in that case, you'd use the board A0 with the tofu with the cellular radio, and then you connect back to your full node back your house or something that's running your Lightning node. So there's really kind of 3 computers involved potentially to make distributed charge work. There's kind of the control system in the car, the Lightning node for the car owner back at their permanent location, and then the charge controller's got a Lightning node built into it because it's not mobile. So
wow, so you you've really allowed for the verification that the node allows you to do, along with an external way to connect to that, wherever you are, since you're in a car.
Yeah, and one thing, one reason that, I wanted to separate the Lightning node from the control system in the car is because, as a person, or maybe even you as a family, you really probably only want one Lightning Network node for all your spending, or receiving. You don't want to have a Lightning node for every application. So, I don't know what type of wallets you use on your phone for Lightning, but for me, it's, Zeus, and Zeus can connect to the same Lightning node that my car is connected to. And then, I'm sure there's other devices you can connect back to that same node. So really the goal is to have a single Lightning Network node that every device uses, and then you can kind of monitor that from multiple, means. I know there's a lot of desktop clients that you can monitor your node from, so you can monitor what's going on with your node in a variety of different ways, which is kind of cool to build around that, if that makes any sense.
Yeah, because essentially what it sounds like, Andy, is you use Zeus, but any mobile wallet that might connect to your node would also do the same trick.
Yeah, I think there's another one called Zap, maybe. I don't know if that one's still under development because Zeus is getting pretty big, but there's a few different options to connect to your node from your phone. And I think for desktop, there's Ride the Lightning is one, and I think Lightning Labs might even have their own now. I can't remember, but there's actually quite a few choices. I even have one called LN Top, which is just a command line Lightning Network GUI, basically, so I can get on a terminal and just monitor my node that way. So there's so many ways you could look at your node, just because of the way the node implementations have these RPC interfaces, and then people build a lot of infrastructure around those RPC interfaces.
Yeah. And this is probably getting into now the conversation around what you wanted to talk about, which is what problems are left to be solved, and on top of that, what else needs to be done in order to basically obsolete everything else.
Yeah, I mean I guess kind of the statement I made to you offline was, I really want to get to the point where, we're basically not trying to convince people of the why of Bitcoin, because that can be such a tense thing. I mean, I was at a Bitcoin meetup last night, and somebody showed up who was very critical of Bitcoin, and it's I'm tired of having these conversations. I want this technology to be so awesome that everything's just completely obsolete. That's not Bitcoin. And so that's really my driving force here at this point. And there's so much to do to get to that point. I mean, there's a lot of things that can ease just general onboarding to the Lightning Network, and so many other people are working on that, which is awesome. I think one that's a little bit more foundational that is maybe overlooked, but I think the transition from IP version 4 to IP version 6 is really going to be necessary to scale this thing big. And, I hope more people can start talking about that one. Are you familiar with version 4 versus IP version 6?
I am not, and our listeners, may or may not be, so could you enlighten us?
Yeah, I mean, IP version 4 was kind of the internet protocol that I guess kind of was mature enough that the internet evolved around, but I think the big barrier is limited IP address space. So IP version 6 aims to fix that by increasing the address space like dramatically so that every single device in the world can have a public IP address that's directly addressable. You might not always want that from a privacy perspective, but you may want it. So, the good thing with IP version 6 is you can have it both ways. Whereas right now with IP version 4, with the limited address space, there's really a couple things that happen. One, everybody's local network is got private IP addresses, and then there's something called network address translation that then kind of merges those all into a single public IP address. So that's going on, which kind of limits people hosting their own devices locally without like a lot of poor translation and stuff like that, which it can work, but it's a nuisance if you're trying to run several different services and whatnot on your internet connection. But I guess the other problem is because things have sort of evolved where people can't like self-host easily, then all of these services out there have kind of evolved where they're trying to create like themselves as a middleman in order to make it easier for people. But then they're all getting so big that it's like starting to be like the only type of product offering where you have this middleman, and all this middleman is doing is really helping to get around the IP address limitation problem without people knowing how to do the port translation on their local router. And I really would like to see it kind of flip from that, where there's not an incentive to have a middleman routing your data around, because there's plenty of IP addresses and you can run as many services as you want locally. Does that make sense?
It seems like there was artificially enforced scarcity based on the protocol in IP4 of IP addresses, and so it naturally developed this middleman kind of mentality, or I guess that was kind of the paradigm.
Yeah, I mean, it definitely turned into what you just said. I don't know if it was artificial at the time, because like computers couldn't handle as much data. But once IP version 4 started to get so popular, it was just hard to switch to that next standard. So there's been initiatives to change that, but there's also people holding it back, and like it seems like the Lightning Network is trying to utilize Tor as kind of a workaround to that problem, which kind of also gives a little bit of privacy. But the Tor network isn't totally decentralized from what I understand, because you have to have like a node list that you bootstrap your connection from, and that's a real problem. And Tor is also very slow. So I think the solutions people are making with Tor are giving like a good user experience at the expense of speed, and also like it's not going to be scalable is kind of the way I'm thinking. So that's a bigger problem with the whole internet, I guess. It's not a Lightning specific problem. but it's going to affect onboarding of new users to the Lightning Network. So, but you had other questions, which was, well, you led off with, what are the problems that need to be solved, and I guess do we have enough time to get back to problems that I'm trying to solve and not general Lightning Network issues, or where?
Oh, of course. Please dive into those.
Yeah, so I haven't got this working with other cars yet. It's just a Tesla Model 3. I think the Tesla Model Y is going to work plug and play, but I haven't tested it yet. But there's a whole nother type of car out there that's not a Tesla that this needs to be working with. So that's, an area of development for sure. For those who might not be aware of charging technologies, there's level 2, which is, basically 220 volt AC charging, and then there's level 3, which is DC charging, and I really need to get this working for DC charging because it's a lot faster and it's really going to become a much bigger thing for public charging, just because the AC is really more for overnight charging, which is kind of usually used at your home. But when you're on the road, which is where you're going to most commonly be using a public charger, you're going to need DC charging. So I need to get this working for that. There's non-EV applications. Did I mention that much, or do you have any interest in that?
No. Yeah, take us through those.
Yeah, so EV was just kind of the first example of using Lightning Network for energy payments, but this can be used everywhere in the energy grid and really allow for bidirectional metering between, basically electricity peers is I guess what we could call them. And, right now net metering is kind of at the mercy of the utility operator in the region, and there's only one utility operator in the region. And that's really because it's so difficult for people to set up new infrastructure because, you can't have 5 parallel power lines running on, the side of every road, just for practical reasons, but it's also just a nuisance for the current utility provider to get all the, land agreements. But if people are going to have, net metering with their peers without, having another party involved, the grid could potentially start to migrate towards something where rather than have land contracts for the power lines to cross, people are then able to charge for the energy that's moved over their property, and then they can, be more appropriately compensated for the value of where their land is positioned, but also it can be more of a, person-to-person interaction rather than have a central group kind of establish the prices and the rates for everything.
Wow. Yeah. So we're more appropriately measuring, the actual price of energy here, what it costs to deliver, and even taking into things like you mentioned, where your land is positioned. That's incredible, and something you don't get in the current milieu.
Yeah, I mean, it can really incentivize people to put power lines on their property, but also generation, energy storage, it can more incentivize, a consumer to start up some sort of, industrial operation in a certain place based on, the rates in that location. But, all this different pricing needs, some type of protocol to, agree on the rate structures. And that's another big area where, it also applies to EVs as well, but there really needs to be a automated bidding process for, who's going to pay for a certain amount of energy, and then an energy delivery rate at a specific time. So there's really a lot of like instantaneous stuff that can happen with the Lightning Network. As far as pricing goes, that doesn't really necessarily exist as dynamically or as clear with other utilities.
And it's not tied to a specific locale. Now we have this underlying protocol that's global that does this in real time across the world.
Yeah, I mean that's a cool thing that just doesn't really exist with other technologies, that I'm really aware of, I guess.
Yeah, me neither. Perhaps someone can bring it to our attention.
Yeah, I mean, so there's that, and I mean, there's just general polishing of the user experience for the EV charging, and then really streamlining some of these grid type of interconnect applications. Those are some big areas, for me, as far as what's to do, but. Yeah, I mean, there's so many things that could happen, but what's cool is, different people can kind of play a different part as far as, what they're developing, and then, it can plug in together. So this can be a lot bigger than me, and I've released the source code for my EV application with the Tesla project so other people can, tinker with it, and I really want this to be an open protocol for an open charging network, and the same thing goes, for the energy grid, interconnect type of application, and there's other applications like campers and campgrounds plugging in, and sub-metering inside of rental properties. So there's a lot of other implementations to build, but I want to keep each of those open. And I want to provide software for people, or not. I want to provide that open source software, but the hardware is really what I'm trying to provide to people right now. So that they can make this happen, and I hope they'll use my software. But if another software comes about, they should still be able to use it with my hardware. And then kind of the same thing goes the other way. If they're not happy with the hardware that I create, maybe they might still use my software with some different hardware if it's maybe better for a particular application.
That's really cool. An open energy network.
Yeah.
Well, Andy, this has been an awesome and wide-ranging discussion here. Where can people find your work? Internet, social accounts, whatever you want to share.
Yeah. So I'm primarily focused on my website, andyschroder.com. I just prefer that because it's not a central company that might be kind of an intermediary from you connecting to me. So yeah, andyschroder.com. You can find the distributed charge project under there, under kind of the Bitcoin section of my website. I got contact information listed as well on a contact page. So I'd encourage you just to kind of check that out if you're looking for more. That's where everything will be stored.
Great. Well, thanks again for your time, Andy. It's been awesome having you.
Yeah, thanks for having me on.
Wow. Okay, 2 quotes that stuck out to me. People need to see what their Bitcoin can buy them. So when you're using it as the medium of exchange, he talked about this with me offline before the recording. The idea is that you can spend so much time convincing people of the why. They ask the question, why would I use that? Well, see what it can do for you. See what it can buy you, I should say. And the other one is they can see and feel what Bitcoin is doing for them in these projects. And so when it comes to a medium of exchange, we know what we get if we exchange dollars. Now, over time, we also know what we don't get if we keep paying for things in dollars. in the United States at least, and also across the world because it's pretty liquid. It's very used across the world. But the idea is, in this case, it's a medium of exchange. It's just a matter of, have we built the tools to make it that across multiple industries, across multiple use cases? And so the fluid dispenser one was perfect. Just the idea of everywhere from fuel to water in areas that aren't served, let's say, by a city water project. And then you also have even down to farmers and being able to get freshly dispensed milk and or honey. That was obviously, like he mentioned, maybe less of a use case, but can you imagine that the industrial age turned our food supply into a mass-produced system in which a lot of the good stuff, think raw milk, for instance, or raw honey, a lot of that has been stripped out, industrialized, the nutrient content has been dramatically decreased or just completely eliminated whatsoever. Can you imagine that Bitcoin in the information age, money become information, actually leads to a relocalization? And so we got to get him connected with people like Untapped Growth and Texas Slim, because there might be a lot of things going on in synchronicity there. But then the other aspect is they can see and feel what Bitcoin is doing for them. And so when it comes to, again, the ability to see a medium of exchange and what it can do for you, spending so much time on the why is unnecessary if you show them the how. And so definitely a huge builder. And Andy just came across my feed from the product manager, I think, at Cash App, Michael Rihani, I believe is how you pronounce his name. And so thank you for that, Michael. You probably don't even know, but this was a really fun conversation. And I think there's a lot to this in distributing. Peer-to-peer interactions and transactions is what Bitcoin is all about. And then Lightning Network is just an accelerant for that, as the Spiral folks have said recently in their video. So in any case, thank you so much for those of you who have tuned in. If you would consider streaming the show Sats, this podcast is sponsor and ad-free. And so the way that it is supported is via the value for value apps. Fountain, Breeze, Podverse is one that is currently in beta, and I think it's on test flight for Apple users. I'm not sure about the Android version, but yeah, any support that you would be willing to show would be much appreciated. Any value that you've received, an equivalent value in return, would be much appreciated. And yes, until next time, keep changing the tide.